So in the last couple of videos, we've established some new derivative shortcut rules. We've established that the derivative of the sine of x is the cosine of x, and the derivative of the cosine of x is the negative sine of x. And what's great is that we're actually going to be able to use these particular rules in association with the quotient rule that we learned about in the last section to actually establish derivative rules for all of the four remaining trig functions. I'm going to show you here how this works on part A of example 2. Here we want to find the derivative of the secant function. All right, so if I want to find y prime, or that is, I want to find dy dx, however you like to express it, I know that means I'm going to be taking the derivative of the secant function. Now, if I'm taking the derivative of the secant function, I should be able to note that the secant function is really just 1 over the cosine function. And so immediately I recognize, oh, perfect, the quotient rule could be used to help me with this. So let's go ahead, and on the next line, I'm going to go ahead and work out what the quotient rule would state. So remember our setup for the quotient rule. We'd take the denominator and we'd leave it squared down there. And then we would put it in the numerator left completely alone. Then we could start by going ahead and multiplying by the derivative of the numerator and kind of fill in like a pseudo product rule up here, except we know that it has a subtraction in the middle. So let's see. I would start with the derivative of 1. Well, the derivative of 1 is just going to be 0 since 1's a constant. Then I would subtract and reverse the order. I would leave the 1 alone and then multiply on by the derivative of cosine. But we just established that the derivative of cosine is the negative sine. So what I end up with here is actually going to be, in the numerator, a sine of x, and in the denominator, a cosine squared of x. Now this is actually a perfectly valid spot to stop for the derivative of the secant, but it's a little bit maybe difficult to remember. I'm going to go ahead and take this a little bit further by writing this actually as two separate fractions being multiplied together. I'm going to leave it as 1 over the cosine, and then a sine over a cosine here. Notice again, when I multiply these fractions back together, I only get sine in the numerator, and I get cosine squared in the denominator. But now I can actually see that I can take both of these fractions and rewrite them as other trig functions. 1 over the cosine ends up being the secant, and the sine over the cosine ends up being the tangent. So the derivative of the secant function is secant x tangent x. So this is how I can use these first two rules as well as the quotient rule to help find derivatives of functions like these. Now I'm going to actually ask that you go ahead and try out parts B, C, and D on your own. See if you can do the exact same sort of a setup. Again, keep in mind that you're going to be interested in trying to find, in this case, the derivative of the cosecant, which means that you would start by rewriting this as the fraction 1 over the sine of x and using the quotient rule. You would do the same thing with cotangent. You would just write it as cosine over sine and try to use the quotient rule. Same thing with tangent. You do sine over cosine and use the quotient rule. See if you can go ahead and work through these. I'm not going to cover these answers in the video here, but you can take a look at the solutions, which are going to be posted up online in Blackboard.